Good morning. Good morning. Good morning. Hello and welcome. Good morning, Chef. Good morning, Uchu. Good morning, Giovanni. Good morning, Fuzzy. I'm doing okay today. We'll see how you all are doing in just a moment once everyone hops in here, and we'll talk about a little bit of the nightmare we've been experiencing, huh? Good morning, Brandon. Good morning, Pig. Good morning, Oyman. Good morning, Cade. Good morning, Waffle and Synthos. Giovanni. Okay, I will say it like that from now on. Thank you. Okay, so we've got 18 viewers or so. That's enough for us to get started. All right. As I said, assignment 1 has been a little bit of a nightmare for some of us, as I can see. As I said last week, these past few semesters of CS 202, we've been all of the instructors have been collaborating together to make the assignments together. And I have experienced many of the assignments to be quite confusing. Now, I've always been very good, at least I think I've always been very good at editing the PDFs before or editing the assignment if I think it's too confusing. Obviously, this assignment 1, I kind of just sent it out there without going over it too well. And as we can see, it's kind of a mess. So here's kind of my recommendation to you. Today I will offer a little bit of help with assignment 1. It is a CS 135 review, though it may be one of the larger programs you've coded before. There's nothing in there that you shouldn't know about. And I want you to work on your kind of problem solving skills. So kind of as I said, that PDF was a little bit confusing, and I just want you to kind of do it whatever way you think that you can. So anything that's in that first PDF, I want you to take it as a suggestion, not like it's a skeleton code that you have to follow exactly. You can use whatever functions you'd like. For example, last week I had the example program in class. You can take anything out of there that you want. You can keep the same function names that you want, any of that. Now, in an attempt mainly for those of you who are having trouble getting started, I did upload that new PDF yesterday. Now, that may have confused some of you even more because the functions are not the same. If you got started, I would just recommend kind of taking bits and pieces from it. And if that's all of that, if that can't help you enough, remember this. I don't know how you guys are as coders. I know that I rely heavily on things like the sample outputs. And I know in the PDF, some of that stuff is not included. So all you have to do is, if you want to see how this program works, just come to our files tab here. Let me see if I can zoom this in for us just a little bit. Or a lot of it. Come to the assignments and look at the sample outputs. I promise I will always upload these. And so if you open them, I might have to download them depending on how fast it is. That looks fine. So this is exactly what I'll be comparing with on CodeGrade. So when I say write to the log, you go, how do I do that? Well, go ahead and come look at these outputs. And look, you can see that this is probably our old word, right? The unedited word. And here's what it changed to. Now, code grade will ignore all of the white space here, so you don't have to worry about matching up the tabs or the spacing or whatever. Just make sure that you've got the old word here, you've got this arrow, and you've got the new word. So how do I write to the log? Well, match this format here, all right? Just match this format. You say, well, what does the unigrams file look like? Well, open this file. I did make an update to the PDF, but up here we're going to print the number of unigrams. And then we're printing out that unigram dictionary, as I called it, or the unigram array, whichever one you did. All right. You say, what does the bigram file look like? Well, here it is. You can look at it. And then you say, well, what's the flow of this program? Well, I ran it for you in class, and here's an example run. Now, notice I didn't update this one with the new file, but that's fine. It still works the same way that it would. Yeah, so in 135, they usually had it in the PDF. Personally, I hate that. I think it is kind of roughly included in the original PDF, but I really don't like that. I would much rather you have the text file, because that's like the source, you know. You can see exactly what's going on in there. So for those of you who didn't know, go look at those, all right? Those, I mean, like I said, I don't know how well you code or how you understand things. But me, myself, I can just kind of look at this example run and somewhat understand the flow of this program. All right. So just do that. Take a look at that, please. Code grade is up. It's running with the smaller file. And let me just kind of say this, since I've got 28 people here or so. I know many of you might be scared right now. I promise in the future I will be watching these assignments like a hawk, okay? So please, don't drop if you're thinking about it. Not yet. I'll let you do it in a week or two. I think we've still got a date where you can get refunded or something like that. I'm not so familiar with that, but for now, please hang with me and do your best to just get this done. Once this 135 review is done, we're off and running with our new stuff, okay? And remember, we can only get stronger from this experience. I've been coding for probably 8 years now, and even now I still run into problems today. And each experience we have makes us smarter programmers. Of course, I'll have office hours after class, so please come to those if you'd like. I have been responding to messages. You can always message me. And as I said, I'm going to take the first few minutes today in class to maybe go over some assignment 1 things. So, does anyone have any suggestions? Is there something in particular that really, really bugs you? That's like you're banging your head against the wall and you don't know what to do that I can maybe help you with? Are there any suggestions? Okay. The log file, I like that. I like that one. All right, so let's kind of talk about it in terms of both PDFs. Yeah, so the clean word function I did in the video doesn't log anything. So in this PDF, the function that is responsible for that, let me go take a look at it, would be this one here. All right, it would be this cleanup one. Now let's see what I did for my updated PDF. Let's take a look. And I said that's the clean words function, okay? That was the clean words function. So we're going to kind of do it like that, all right? Let me just open up a fun little text file here. Excuse me. So this will be a1 help.cpp. Now, for those of you who are struggling with structs, this week we're going to begin with our object-oriented programming. This class is completely based around things like structs. So you're even going to get more information on how structs work today and tomorrow and for the rest of this class. probably bring in another. We'll probably bring in maybe the F stream here. That's probably good enough. So I assure you, pig and male, that structs will make a lot of sense very soon. I know that they were just kind of briefly introduced. So we're talking about logging stuff, all right? We're talking about logging stuff. So we're going to hold off on whatever, kind of the unigram part of it for now. We're just going to assume that we've got maybe an array of words, right? So I'm going to assume that we have some of these functions. Now, the main one I'm thinking about is void clean words, all right? And that's going to take in, of course, an array of words and maybe a word size, right? Just, this is the size of the array, whatever we named it. Now, I'm going to pretend like we have some extra functions, okay? I'm going to pretend like we have some extra functions. Void, maybe something like that, which takes in a string s. It's not a void. Now, I'm going to let you do these on your own, okay? I've kind of gone over some of these already, so I'm just going to assume like these exist. Another one will be maybe to remove symbols. And then another one will be convert if numeric. All right? So this one is just going to convert all the things to lowercase. This will remove our symbols. And then this one's going to convert to non-alpha, if necessary. All right, so whatever you have, right? Whatever you have, whether it's in a function or it's manually done, like in spaghetti code, that's fine. So let's pretend like we have these. And then this is our clean words. The library cade for 2 lower should be this one. Or maybe this. And if you're having a problem with it, make sure that you're compiling like this. I don't think you would have any issues with that. And if you do, let me know, but it should just be there for you. So we're gonna write this clean words function, and we're gonna say we're gonna do the logging part of it. So I kind of had 2 suggestions for you. Now this one I prefer. I like to throw a bool in here to say log changes. All right, I like to do that. And some of you were like, what is that? Why are we doing that? And so I'm pretending, for example, somewhere here in main, we're going to pretend up here we've got some code. And then down here we've got the rest of our code. And right here we're going to say, hey, cout, would you like to log changes, my guy? And then we'll say cin to some character. I assume that's how we did it. Cin to C. And then we'll say, hey, if RC equals, say, yes, else no. So I'm going to pretend I have this bool log changes here, which is equal to false. And if C equals yes, then maybe we'll change it to true. All right. So is everyone okay with that? I mean, obviously you'll have to match my output here, but you're going to ask them, you're going to see in this, and then you're going to maybe flip a bool here. You could pass a character instead, whatever you want. And then what are you going to do? Well, you're going to have maybe your string words here somewhere, the array max. Remember to change this to 5,000, please. If you have it as 50,000, your program might segfault. I made this change. I kind of announced this a few times already. Please do this. And you'll be, when you go to code grade and you submit your program, you might get it wrong. And it will tell you that if you have 50,000 or 5,000 here, okay? So make sure you change that. And then we're going to pretend like we've got some words here, right? int word count, size of array, equal to, I don't know, maybe whatever it's equal to. Let's pretend it's equal to something. And then finally, we're going to call clean words. And when we call clean words, we're going to pass in that array of words, whatever the size of the words is. And then we're going to pass in, say, this log changes. This is our function call. Now, what if you did it like the original PDF and you say, hey man, I really don't want to change my code. So here's the original PDF, right? It's kind of hard to see maybe, but you probably did this function. You said, I didn't pass in a bool. Well, you want to know what the easiest way to do this is? If you don't want to change everything you did, why don't you just take out that bool there? Take out the bool here. Take out this bool. And then why don't you just cut this bit and put it in here? Are you guys okay with that? So the very first thing you can do in your clean words function is ask for the log, if you want to. That way you don't have to change up any of what you had. Just put it here. So now we're going to do some stuff, okay? Now we're going to kind of have our for loops. So what are we going to do for the logs? Well, let's say we've got a for int I is equal to 0. I is less than the word size, right, for that array. I++. So this will be for all of our words. And so the first thing that we'll do is, if you follow my new PDF, you go look at it. Whoops. I kind of gave you the flow here. Convert all letters to lowercase. So that's the first thing you should do. Now, some of you ask, are we logging this? Well, I did include it in that PDF, but if you come look at whatever that file is, as I said, the sample outputs, let me go find it here. Are we logging the lowercase stuff? Well, if you look here in the log, we're actually not doing it, okay? You'll notice that none of these, as far as you can see, there's nothing where anything on the left-hand side is uppercase, and anything on the right-hand side is lowercase. Chef, you don't have to split it up, all right? I'm just making a suggestion. It's also making it easier for me to kind of give you a skeleton code. This code that I'm typing here, I'm not even going to run it. I'm just kind of compartmentalizing. I can't say that word very well. I'm just kind of putting these functions here so you guys know what's going on. But if you've already written it like here, if you already wrote the convert to lowercase without a function, that's fine. But keep in mind that this is kind of how we're going to do it. So the first thing you want to do is convert everything to lowercase. So that's going to look like this for me. Now, for some of you, you might have a for loop here that goes through the words I.size, right? But that's the very first thing we do. Now, the next thing we need to do is remove the symbols. So I would like to do this. But can anyone tell me what's wrong with this if I do it? Can anyone tell me what's wrong with this if I do it? Do you know immediately what happens here that kind of screws me if I overwrite words I with a remove symbol words I? There are a few of you who were able to complete the assignment. I think two people I see managed to do it. Does anyone have any ideas? Kate says it will take back the capitals. I don't think so. Yang, I think Yang, you're kind of on the right idea. Think about it this way. I want to say somewhere here, I want to log this. So I'm going to say if log changes, I'm going to want to, let me do a few things here real quick. I kind of am skipping ahead. We are going to need an out file here. See, I think it's spelled like this, maybe without the o1.txt. I actually don't want to open it unless it's in there. Okay. So what I'm looking to do here is if log changes, I'm going to want to write to our out file. And what's the first thing we write? The original word. And so this is a yes or no question. If I do this, do I have the original word still? The first thing that needs to go here is the original word. No, I don't have the original word, right? So I need to kind of come up with something special here. So I need to do something like string new string. And then, can anyone suggest to me, how do I know if the new string and the old string, how do I know if the new string has symbols removed from it? What's the easiest way? How do I know if the new string lost some symbols? Let me see here. We can look at it. I like the size, right? If we lost some symbols, the string is now shorter. The string is now shorter. So we're going to log it then. So we're going to have another check in here. You could do if and. You want to do some ands. I think you guys would benefit from seeing something like that. And if the new string dot length does not equal, sorry, that's my SQL coming out. Does not equal the words I dot length. You okay with that? Sorry. So if we're logging the changes and symbols were removed, right? So we're logging the changes. That's a Boolean. Some of that, I see this a lot on I follow a programmer Reddit post. Do you guys understand that this check is legal, but it's very redundant? If log changes is true, return true. So you're welcome to do this, but it's very redundant. I see a lot of students do something like that. It's just a Boolean here, so we're going to leave it like that. So if we're going to log the changes and the lengths are different, then we're going to go ahead and outfile it. The original word is here. And then we're going to need an arrow, maybe with a space. And then we're going to need the new string. That makes sense? So if you are removing symbols in a different way, with like a for loop, you're probably going to start it out with maybe an empty string, right? Which is kind of what I went over previously. But make sure that you save it to a new string. Don't make an edit to the original one until you know if they changed, right? We need to be able to check the lengths. Now I have an error there. That's fine. I'll just fix that. All right, so now we're going to do the next thing, all right? Now we're going to do the next thing. I'm going to kind of just copy this little bit here. And I'll put some enters. Some new lines. So finally, here we are. We're going to convert to non-alpha. So, Mail, I've said this a few times. In code grade, if you lose a ton of points because your output doesn't match at all, for example, say you run into problems and you have to cram it and there's no possible way that you can get the outputs to match in time, I will manually check those assignments. And I will see if you deserve to have more points than what code grade thought you deserved. But for those of you who get the 10 out of 10 right away, I'm probably not going to review them, depending on the assignment. I'm probably not going to review them. Does that make sense? Chef, there's kind of some confusion. Well, let me just just to fix that, I just want to make sure that I didn't screw anything up here. I had a clean word, and then I had clean and store array. So that might be a little confusing. This should be that one. Which is also, I think, equivalent to the generate unigram function, I think. But I kind of made these functions, right? So finally, we're going to convert to non-alpha. I'm going to use this new string here again. I have it up here. And I'm going to convert to, I think I named it this way, to convert if numeric. So tell me, what's the check that I do here? What's the check you think I do here? How do I know if it changed? How do I know if it changed? Is digit will only work for a character. So you would have to go through the whole old word to see if there's a digit that exists. That would work. Is there a simpler way? Is there a simpler way? Any ideas? What about this? Are you okay with that one? So that should do it. Pretty sure. Let's go find my web campus here. And here you go. So this was converted here to non-alpha. So we logged it. So you'll notice a few things happen here. The very first thing that happens is whatever this is goes to lowercase. Now we're not logging that part. So notice that that gets covered here. And then the next part is we're going to remove any symbols. That's the very next thing that happens. So you can see here that it works, right? Symbols are removed. Now this one doesn't contain any numbers, so it's done. But this one contains all the numbers. But notice before that happens, we remove this dash. Notice that the dash is removed. And then the very next thing that happens is it's converted to non-alpha. Now, I'm just now realizing that I made an issue here. I made an issue. I have a bug. I do want to overwrite words I with the new string at the end. Can you go over the conversion from 8859-1 to 8851 before you convert to non-alpha? So that happens here. Now, I'm not going to type it out, but if we go look at this bit, I think this clean word function that I have from the old one, you'll notice here that this bit is what removes the dashes. So pretending we have some string here, some string S. If we go through the whole string, we'll just see if each character is an alphabetical. I think I want to make it like this. I kind of really, I really made that. Well, in your assignment, you're going to want to use is alphanumeric, or however it's spelled. It might be is alnum. For the purpose of my example, I was using something else. But this is basically the code that will convert, that will remove symbols. It will go through the string, character by character. It will say, is this character an alphabetical character or a number character? If it's one of those, then we're going to add it to the new string. We're going to add it to the new string. So that's what that bit does. So the very first thing here that happens is the remove symbols. When I call remove symbols, this is basically the code that executes. And then I call this one next. So notice before I convert anything to non-alpha, I try to log the changes. So I remove the symbols first, and then I convert it to numeric. So there's a lot of questions going on here. So let's see. G-Man, I'll add it to Canvas, sure. This code probably won't, I mean, it might compile, but it definitely won't do anything, all right? So this is specifically for reference. But I will. Yes. Giovanni, yes. When say for example here, when it loses the dash, the length of this string is 6. The length of this string is 5. The length of this string, I'm not going to count it, but I know that it's the length of this string is greater than the length of this one. So the symbols are removed, and then it gets caught by the length check. And then once the symbols are removed, we check for the number. YCS asks, the out file will be outside the for loop? Part of it. There's kind of two parts to it here. There's going to be one that says out file. It is outside the for loop here. We do open it. We do open it outside of the for loop. And then you're going to want to print this. And then in here, you are going to write stuff to the out file inside of the for loop. And then once you're done with it, you'll say, hey, I'm going to close it. Okay, I'll give you this one. So basically, how do I know if a string has a number in it? I kind of said it there, right? It has a number in it, right? So what function should I be using to check to see if there's a number in it? What function should I use to check if there's a number in the string? Hamma, would you please tell me what you're referencing? I'm not sure what that is corresponding. Pig says, I'm not seeing the old CPP files in Canvas. They're in the class code. They're here. That was the notes from the first day. Here are all the CPP files that we did. So Synthos says, is digit? Yes, that's correct. So I'm going to check to see if any character in this function is digit. If I know it's a digit, if I know I found a digit, what should I do? Oh. Hamma, you might be, if you're talking about, are you suggesting something like this? If I have like an int? Well, come to office hours if you want to talk about that. For the purpose of this assignment, I don't think that'll work. But if you want to talk about that, please message me or come to office hours. I kind of don't want to go down that rabbit hole. But as for this, we're just going to check each character if it's a digit. And if we find the digit, what can we do? What's the answer here? If I find a digit, what can I do? What does it mean? What should this function do as soon as I find a digit? Yeah, you said convert to non-alpha. How about we just do this? Are you okay with that? Now, if we go through the whole string and we don't find it, if we go through the whole for loop, without finding a number, then we'll just return the original string. That's it. Does that make sense, Chef? So, kind of to wrap this up, this function you might be able to pretty much copy paste as long as you have these functions. If you don't have these functions, you're going to have to replace this line of code with whatever you did, this line of code with whatever you did, and then I gave that one to you. So I also gave you the code for the generate unigrams. To generate bigrams, you'll have to change up that code a little bit. But roughly, that clean and store array kind of does a little bit of both. Let me show you where that is. Excuse me. So here, I'm cleaning all the stuff. All right. You kind of don't have to... Well, let's see here. This part you won't have to worry about. But this is the code that will generate your unigrams. All right? If you want to go over that, please watch that YouTube video. You can skip ahead. I think I did kind of go over that pretty well. So for the most part, everything should be doable. I promise that there's nothing in there too scary. I guess it is just we've had a whole summer. Some of you maybe didn't code a little bit, and we just need a refresher. So is everyone okay if we move on here from assignment 1? I think that we were able to cover most of the functions, at least the hard ones. Yeah, of course. And if we do have hard assignments in the future, I'll kind of always take a little bit of time to go over stuff like this. So like I said, please hang in there. But for now, I'm going to go ahead and move on from this, all right? So for those of you who want this, how about I give it to you right now? And are there any other questions before we move on? Today's the 31st. Assignment 1, classes, overloading. Now, someone asked me last class what a function overload was. And I think the PDF for assignment 1 talks about function overloading, doesn't it? So that's my bad. I think the PDF for assignment 1 does talk about function overloading, and I was just oblivious to that. So let's go ahead and go over that real quick. And Top Wolf asks if you used a different method. As I said previously, you can do this assignment however you want. I just want you to prove to me that you can code a program with CS135 concepts. So like I said, if everything is spaghetti code in main and there's no functions whatsoever, I will accept it. However you did it, I am okay with it, as long as it works. So we'll go ahead and get started with our notes for today. I don't want to open them there. So the first thing that we talk about in this class is function overloading. Now this is a very, very small subject. We might spend 15 minutes on it. So, talking about functions, we're going to go back. First, we're going to review something. If a function is called in main, this might be seem a little bit like a silly question. how does main know where to find the code for the function? So that's my first question for you. It might seem a bit silly, but I want you to answer it. Giovanni, the libraries we give it, perhaps. I'm talking about functions that we define ourselves. The functions that we define ourselves. Now, Synthos says parameters. That is correct. And you say the function definition. So there's two things I'm looking for here. One is the name of the function corresponds to the definition, right? So kind of that, in terms of, say, the assignment, we might have 20 functions. So if I call that function in main, how does it know which function to go to? Well, the first thing is the name. The first thing is the name. If I call foo, it's going to go look for foo. If I call clean word, it's going to go look for clean word. Now there's a second bit here that Synthos mentioned, which I'll just kind of point out here, parameters. And parameters is the, it's kind of like the key to function overloading. It's kind of like the key to function overloading. So let me ask you this then. Let's go ahead and get our file going here. I'm going to come over here and I'm going to grab my favorite stuff. I don't need this stuff today. And I'll grab, say, this. And that'll be good. So let's say I have two functions here. Now I'm going to do something very simple. Int add. Now you say that's kind of silly. That's kind of silly. We already have something for add, right? It's the plus symbol, but bear with me here. So let's say this one takes an int num1 and say an int number2. And what this function does is very simple. It returns n1 plus n2. And this one will take two strings s1, string s2. Now, for the fun of it, I'm not going to do it the way that you might think I would. Instead of concatenating them, maybe I'll change it up a little bit. Maybe I'll just return the S1 length plus the S2 length. All right, so here we have two functions. Notice they have the same name. Notice they have the same name. So I'm repeating myself here. Absolutely, I'm repeating myself. But please, like I said, bear with me. If I call add here, which add does it call and why? Notice the names are the same. There's this add, there's this add, there's this add. Which one does it call? It calls this one. And the reason is because the parameters match, right? Because we gave it integers. That's exactly right. So the definition of function overloading find as functions that use the same name and different parameter lists. All right? That's it. That's it. Function overloading is defined as functions that use the same name in different parameter lists. So, if you really wanted to, you could have all sorts of adds. Now, the typing doesn't matter. I don't know why I did that. I'm not interested in that. Please correct yourself. Okay. Do they have to have the same amount of parameters? No, they do not. No, they do not. And so let's kind of pull up some examples here. Let's pull up some examples. Hey. So, to answer the first question from Giovanni is roughly, how do I know? I'm going to have to add some floats in here, I think. So if I call this one with F1 and F3, we're going to go look for the one that has the matching parameter list. So it's going to go find add float float. Now if I tack on another thing, say an int, notice that the parameter list is still different, but the name is still the same. It's going to go find the add with the matching parameter list. Float, float, integer. So we've got a float, and an integer here. So they do not have the same amount of parameters. Someone also asked, do the data types of the functions need to be different? To answer that question, no, they don't. Whatever the function returns doesn't have anything to do with how the function is defined. Well, it does have something to do with how the function's defined, but it doesn't have anything to do with how the function is called. If I say add int float, the only things that matter are the name and the parameter list. Those are the only things that matter. So if you want to talk about this function, let's kind of hyphenate it or abbreviate it a little bit. Function overloads can have different return types. FOs can have different numbers, different amount of params, and FOs can have different types in the params. Okay? So I'll just kind of give you a fun little example here just to kind of show you how things work, just to prove to you that this works. So I'm going to do some couts here. This is how I debug everything. If you don't use print statements now, please start doing so because it will help you immensely. It tells you exactly how your code works. So let's say we've got an int here. This one is a float int. This one here is an int float. This one here is a float float. This one here is a float float int. And this one here is a string string. So let's declare some fun things here. S1 is equal to, this was one of my cats, that was Loaf, and then my other cat is Patty. And so we're gonna do a whole bunch of stuff here. Now I did all sorts, every combination, so that is this is the float. I'm just gonna kind of do them. FFI. This one is an FI. Giovanni asks, this is a great question. What if the two functions had the same names and the same parameters? Well, I will show you what will happen in just a moment. That's a great question. Does anyone have an idea of what might happen in that case? What would happen if there's two functions that have the same names and the same parameters? Maybe we'll do a float float here. This one can be the IF, the int float. What is that? That'll be, I don't know, I guess it doesn't matter. So did I get them all? I need to do the int, I think, and II. I think I called that N2. And then we'll do a string. Some compiler warning. My computer would crash and I would cry. All right, we've got some good guesses. So let's hang on to those. Let's hang on to those for just a moment while I prove to you that this little bit here works as we expect it to. Someone did ask in the... So I had 2 MOBA questions recently. The first MOBA question I had was it wasn't working. So make sure that you download the installer edition. The portable edition will not work. Another question was, what program do I use? It's MOBA Xterm. I showed you where you could find that. You can Google it if you want. You can also go to Tux. It's there for you to use. All right, so here we are on Bobby. Let me just go ahead and pull over our FO for function overloading. Let me go find my favorite compiler statement. Don't worry about that -G. We'll talk about that later. Here we've got FO. And it compiles. So if we run this whatever it is, this program, you notice that the program is picking the appropriate functions based off of the parameter list. So how do we know which function to call? The first part of it is the name. The second part of it is the parameter list. The parameters list. So now let's do our question. What if we had 2 different ones? So let's pretend this. Let's kind of mix it up a little bit. And let me see if anyone's been paying attention here. So answer me this. Does it matter that these have the different return type? Does that matter? In terms of function overloading, does it matter that these have different return types? No, it doesn't. That's exactly right. Thank you for your participation. That's exactly right. It does not matter. How do we know what function to call? The name and the parameter list. So let's say this one works differently. This one just returns the concatenation. So notice, same name, same parameter list. Same name, same parameter list. So down here, I call it. What's the compiler going to do? What's the program going to do? It's going to say, which one am I supposed to call? Well, some of you guessed it might just take the first one. Well, let's go see. Let's go see. We're going to learn a fun word today. Does anyone know what ambiguity means? Have you heard that word before? Ambiguous? Ambiguity? That's a big thing in computer science. We'll hear it a lot, especially when you get to CS 326. What's that word there? So the first thing is the person who had the closest guess was Giovanni. It's not a compiler warning, it's a compiler error. Your program will not compile. And what does it say? That's that fun word I just mentioned. Ambiguous. Ambiguity. Yeah, it means indistinguishable. I can't tell the difference between these 2 things. Let's do let's talk about ambiguity for just one moment. Ambiguous. Fun fact, English is ambiguous. Now here's a few examples of that. There, hopefully I spelled that right. There. What's a word that means two different things, but it has the same spelling? I bet we can even just go to Google and type in ambiguous words. Read, read, yeah. That's a good one. That's ambiguous there. 222, I like that. These things are ambiguous. Now, what do we need to tell the difference? How do I tell the difference between these things? How do I tell the difference? Context, right? Context. Now, context is a huge computer science problem. Context is hard. Context is hard for computers, all right? So this program will not even give you a chance to figure it out. It will not even, it'll say this is not fair. I'm not happy with this. Now we could try to give it some context. I don't think it'll work, but we could try to give it some context. Let's say I say I want this string, new string, to be equal to this. So now we're trying to indicate to the compiler that I want this to return a string, not an integer. Now, I don't think it'll work, but it's a fun attempt. It still is not okay with it. Notice what it's saying here is that can I convert an int to a string? It's ambiguous, okay? So hopefully that makes sense. Whatever that is not allowed. This is not allowed because it's ambiguous. The program doesn't know what to do. Ambiguous. Okay. So that is our chat about function overloading. I will ask you questions about function overloading for the rest of the semester, so remember it. Are there any further questions on function overloading? Two functions that have the same name and param list are ambiguous. Okay. Two functions that have the same name and param list are ambiguous. The code will not compile. So, as I said to that one person who asked me what it was, I think there was some stuff in that first PDF for the assignment that talked about function overloading. Let's go find it real quick just to show you, just to give you an idea what we're dealing with. Now, I'll make it bigger in a second. Let me just find it. Okay, so here was an overload. This PDF, I believe, tells you to make a sort for the unigram and for the bigram. A sort for the unigram and for the bigram. So how do you make it different? Well, for one of these sorts, you provide an array of unigrams. For the other one, you provide an array of bigrams. How does the program tell which one is different? It looks at the types. What are my parameters? I think that's pretty much it. Maybe there was one more, but there was some overloading going on there. Right, so Yang, I did answer that question a little bit. Do you see this down here? We tried that. We tried that. And what did I told you guys that the return type doesn't matter. In the sense the compiler does not care. So this is me maybe trying to give it some context. In some sense, I'm telling it, please give me the one that returns a string. And the compiler just says, no, I'm not even going to try. Please don't do that. So I'll show you that error again. Notice that it did kind of two things here. For one, it didn't compile because there's just ambiguity. It doesn't care that the return types are different. It just says they have the same name and parameter list. Notice the second thing that happened down here. It then kind of ignored that and tried to compile this, and it took the first definition, didn't it? It took the first definition, and it said, hey, I don't know how to convert an integer to a string. So, Yang, I hope that answers your question. To us, that is not ambiguous, but to the compiler, it says, I'm not even going to try. I'm not even going to try this. So that is function overloading. Are there any other questions before we move into the most fun bit of the semester? The most important bit of the semester, I should say. Just gonna make sure we got everything. I told you how functions are called. I defined function overloading. I gave you some examples here, and then we talked about ambiguity. So that should be good. Can always check my notes. So we're about to start about object-oriented programming. Now, some of you have already had a taste. Actually, all of you have already had a taste of object-oriented programming. What in CS35 did you learn that has something to do with object-oriented programming? What in CS135 did you guys learn that has to do with that? Right? You guys got it. It's the struct. It's the struct. That's exactly what it is. Let's look at our notes here. Yeah, I'm not worried about that. All right, all right. It's the struct. Your favorite thing, right? You guys love that. Pretty sure you do. You guys told me, right? All right. So, let's go ahead and get started with that. Now, structs and classes are amazing, all right? They are amazing. So we're going to learn about how these things work, and then you're going to become the best programmers that ever were. Now, object-oriented programming is kind of the way of the world today. Chances are, if you get an industry job, unless you're doing like operating system programming for Windows, you are likely going to be dealing with an object-oriented programming language. So let's talk about this. What are some OO? I'll call this OO. What are some OO languages? Does anyone have any ideas? Now, I don't blame you if you don't. Language. I suck. I know one of you didn't start with C++, or you started with C++ and converted to something. Does anyone know what some pure OO languages are? Java, there you go. Java. This one, C#, for those of you that don't know, that is C#. Those are some pure object-oriented programming languages. HTML, maybe. I won't get into that. I'll only speak of what I know. C++ is partially OO. In some sense, C++ is just C with OO. But you don't have to worry about this for this class. That's not a test question. That's just a fun fact. Object-oriented programming kind of came out. Maybe, don't take my word for it. Go reference it in a book if you want. But maybe 80s or 90s, sometime around then. And everyone was like, this is great. We got to put it in our favorite programming language, C. So they went to C and they added this. What did they add? Well, they added a struct. They added classes and all that good stuff. All right. So O is very popular today. You will likely work with it. So we need to define some things. What is OO? It is a method of programming. What we do in OO. So do not click on that link, please. For the love of God, don't do that. If that was a student, I'm sorry. Do not post links in my chat. Please do not ask for pics or anything like that. I will ban you. And then you'll never be able to ask questions again. That is a problem of streaming on Twitch. I'm pretty good at that. I do apologize if someone ever comes in here and says something bad. I've never really had any problems with it, but I will try to ban them as fast as possible. Thank you for being patient with that. Now, for those of you who know Twitch, you'll notice that I'm not affiliated. You don't get any ads. I made this channel specifically so that it could be for teaching. So this is, I have a real Twitch channel, and then I have this one. So this one's specifically for teaching. We don't get too many of those people in here. Yeah, you can't sub to me. You can't donate to me. Isn't that a problem? I wouldn't want you to do it anyway. This is a UNLV class. This is not a promotional stream. This is a UNLV class. So, back on topic, off of my little rant here. OO is a method of packaging functions and data together. So certain things have data and they have functions that operate them on that. I don't like that. Pig says, last professor gave extra credit if you subscribed. I do not like that at all. That sounds like a lawsuit or something. Please don't, that doesn't sound right. I won't get into that though. So we'll kind of just leave it at this for now, but I just kind of want to give you a small example of that. In some sense, you can only add numbers. Now, that's maybe not a great example because we can, say, concatenate strings, but there are some functions that don't apply to certain types of data. For example, can you take... So, here's something like this. The average function. The average function cannot be applied to a set of words. Now, if you wanted to, apply it to the lengths of the words, you could. Instead, you would take maybe the mode of the words, but you cannot take a mean on a set of words. What's the average of words? It doesn't make sense. And so, in object-oriented programming language, something like an average function could only be applied to objects that would allow that function. So I'll kind of show you what I mean later. I just kind of wanted to give you an idea that there's a lot of functions out there that have nothing to do with specific types of data. Now let's talk about what is data abstraction. That's kind of a test question I like to talk about. Right now, obviously, we're taking notes and we're not coding very much, but that's how it will be until we finish this up. So thank you for bearing with me here. So data abstraction, in some sense, when we say we're extracting something, we are simplifying a data type. And the way we do this is we will hide all of the features that a data type shares. So let's kind of get some examples going on here. Let's talk about, I'd like to talk about birds. That's the example I used last time. Let's talk about a struct bird. Now, every bird, as I said previously, has quite a few things, right? They probably have a wingspan. Are there any birds that don't have wings? If so, please correct me. But for the example, for the purpose of this example, let's assume all birds have wings. They probably have a weight. They probably have eyes. I'm not even going to type that. They have eyes, right? They have a species. So here's the idea. What do we not put in here? That's kind of what I'm telling you. What do we not include? Well, the things that we don't include is probably bool wings. Does a bird have wings? Of course it does. Does a bird have eyes? Of course it does. Does a bird have talons? Of course it does. So what's the point of all bird data types? Why would we put these in here? We know it's a bird, so we're going to hide all of the features that the data type shares. We will only include the things that make them different. Does that make sense? This stuff we do include. What makes a bird different? This makes birds different. This differentiates. Let's see if I can spell it. Differentiate All right. Just don't look at that, okay? Pretend that I didn't type that. We're going to go to my favorite friend here, Google, and then we're going to bring it back. Please don't look at that. This is what differentiates our birds. What does not differentiate our birds? They all have wings, they all have eyes, they all have talons. We're not going to include these things, okay? I think you can clip me. I think you're allowed to. So hopefully that makes sense, all right? Hopefully that makes sense. So that's what data abstraction is. We're going to simplify the bird data type by hiding all of the things that we know it has, and we're only going to include the things that we know makes it different. All right? So now we're going to start talking code stuff. We've only got 5 minutes, so we're just going to briefly kind of get started on that. We're going to briefly get started on that, and then we're going to end class for the day. So, we have used structs before, obviously. And have we used classes? What do you guys think? Have we used classes before? Now, I'm not asking you if you've defined a class. You've defined structs before. But have we used classes? What do you think? Anywhere before in your code, have you used a class at one point or another? What do you think? Let's use our brains. You guys say no. Well, let me give you a hint. Let me give you a hint. Why is this? Why is IntelliSense? For those of you who don't know what IntelliSense is, it's what colors. It's like what colors your code. Why is this one blue and this one green? Strings and ints are data types, right? Strings and ints are data types. Why is this one green? Why is this one blue? Well, a float and an int are both blue. Floats and ints are both blue. Why is this one green? And the answer to that is because strings are classes. Strings are classes. Strings are classes. So look at this. Look at this. Look at this. Say I come in here and I say, hey, I've got a struct, unigram, whatever. It's got an int. I don't know. It's got something in there. And then I come in here and I say, hey, unigram, mygram. What color does it turn? Come on, IntelliSense. It's green. Why? Because that's a custom object. That is a custom data type. It's an object. It's an object. Anything that's green is a class. So, what kind of classes have we used before? Well, guess what? We have used classes. I gave you one of them. What is it? Yes. Yes. We've got the strings class. We've got the ofstream and istream class, ifstream. Those are classes. What else maybe you use? I don't know if you learned about these. I'm going to say maybe. And maybe you did these. Stream. Maybe. Those are all classes. Now, I think Giovanni said this previously. How do we get these classes? Well, we get them through libraries. So somewhere in the library, you've got something like this. And what's inside that string? Well, the blue things are primitive data types. The blue things are primitive data types. So what does a string class look like? Well, it looks like this. Something like that. That's what the string looks like. And it contains the primitive data types. So though this is not important to, say, your test, I'll just say in VS Code. IntelliSense class objects are green and primitive data types are blue. So we're going to leave it there for today, okay? We've run out of time, and I don't want to confuse you too much. I think we have looked at the notepad enough today. So what did we learn today? Well, I gave you some help with assignment 1. I very much believe that you can get it done. I'm here for you. Office hours are at 1. Come say hi. I'll help you. Send me a message. I made it due tomorrow. Pretty sure. So please get it done. We also learned what function overloading is. We'll see it in the future. And we also briefly talked about these 3 things: object-oriented programming, classes and structs, and data abstractions. Now, Yang, I do not have office hours tomorrow. And I don't think that Angela does either. So, Yang, here's what I want you to do. I want you to send me an email and try to schedule something with me, okay? If you cannot make my office hours and you want to talk to me, I want you to email me or Discord message me so I can schedule something with you, okay? If you can't, I should have said that to everybody. Of course, you can message me. If you just message me out of the blue, I probably won't give you a call. You know, maybe I'm watching my favorite Twitch streamer or playing RuneScape or something. I'm probably not going to call, but I will, message you back. But if you feel like you need that screen share time, you can always try to schedule something with me. So go ahead, send me an email or a Discord message, and I'll see what I can do. Before I cut the stream today, are there any questions? If you don't, you're free to go. Thanks for coming to the stream today. I always love seeing your faces, even though I don't see them. I see your colorful names. And thank you for talking to me. I always love that. So, Cade, have a good one. YCS, have a good day. Fuzzy, you have a good rest of your day. I will hydrate. You're welcome, CS202 student. I'll see you later, Uchu. I'll see you later, Yang. Goodbye, Synthos. Thank you. Have a great day, Chef. Klaus, thank you. I'll see you. Oyman, thank you. Top Wolf, thanks for coming. You have a nice day as well. Hamma, thank you. Giovanni, you are welcome. Have a great day. Pig, you're so welcome. Thanks for coming. Waffle, have a good one. Brandon, have a good one. I'll see you guys next time.